The covalent bonds mainly are of two types. One are called non-polar covalent bonds and other are called polar covalent bonds. Now first let us understand how a polarity comes in the covalent bond, and then we will move to understand what exactly are non-polar and polar covalent bonds. See, whenever we have a homonuclear molecular species, like suppose we have hydrogen molecule having two hydrogen atoms or chlorine molecule having two chlorine atoms, since the nuclear pull on both the sides are same, the shared pair of electrons are in the middle. Now such bonds are called non-polar covalent bond, or we can say them the perfect covalent bonds in which there is proper sharing by both the atoms. But whenever we have heteronuclear molecular species, like let us take the example heteronuclear molecular species, like let us take example of HCl. In this what we find is the nuclear pull, definitely when the two atoms which are forming the bond are not belonging to the same element, they are belonging to the different elements, the nuclear pull will be different, and definitely the atom which is having a higher nuclear pull will attract the shared pair of electrons with a greater force towards itself due to its another property which is very high called electronegativity, and as a result what we find is the shared pair of electrons will be more towards more electronegative atom or with the atom which is having higher nuclear pull. Like here hydrogen is having +1, chlorine is having +17, the shared pair of electron is more towards chlorine. So what we find is in such a case electron density on the chlorine becomes high and it acquires a partial negative charge, and since the electrons of the hydrogen are also actually more towards chlorine, the hydrogen is facing electron deficiency, electron density around hydrogen is less, so it acquires a partial positive charge. More electron density towards chlorine giving it a partial negative charge. Less electron density on hydrogen giving it a partial positive charge. As a result, these type of molecules, since they develop both negative and positive charges, are called polar molecules, and such bonds are called polar covalent bonds because they have polarity. Polarity means existence of plus minus charges. So these type of bonds in which the electron pair shared is not mutually shared, it is more towards more electronegative atom or which is having a higher nuclear pull, such covalent bonds are called polar covalent bonds because they have polarity. Now most of the therefore covalent bonds other than the homonuclear one, in fact all covalent bonds other than the homonuclear ones will be having some sort of polarity in them. Now what happens due to this polarity? Now due to this polarity, these molecules or along this bond, attractive force develops from positive to negative side, and this which is called dipole moment represented by symbol nu, and in the molecule it is shown with the crossed arrow whose tail is crossed. The arrow is always pointing toward from positive to negative side. So remember, I am repeating again, those molecules or those bonds which are covalent in nature In them, a sort of a force of attraction develops from positive charge to negative charge, and that's called dipole moment, symbol nu, represented by a crossed arrow, which is a cross is done on its tail. Now this dipole moment is actually equal to the product of charge on these atoms and the distance between them. So Q is the charge and D is the distance between them. Remember, this nu is a vector quantity, and this dipole moment is usually is having a unit called dBi, which is expressed as coulombs meter. Now 1 dBi is equal to 3.33 into 10 to the power minus 30 coulombs meter. And with the help of this dipole moment, we can find out the exact polarity in the molecule and the bond, or percentage of polar character in the bond. Another important thing, this polar character, tendency of what, not mutual sharing of the electron, can also be called a percentage ionic character, because in ionic the transferring takes place. Though this is not a complete transferring, but yes, some sort of transferring is there. So what we can say is every covalent bond has some sort of ionic character, and this moving of the shared pair of electron towards one of the atom is an ionic character. More they move towards one of the atoms, more is the ionic character. Higher is the polarity, higher is the ionic character. So that is what this dBi or this dipole moment, this term is used to find out, therefore, the percentage ionic characters in the bond. Definitely we can imagine, more is the difference of the electronegativity between the bonded atoms, higher will be the polarity, higher will be the ionic character. This is what is the basic thing about this is. Now, we have to go into the details of this dipole moment and try to find out what exactly can be the dipole moments of the different molecular species.